Hello, you're welcome back to this channel. My name is Matthew, popularly known as Huntman. Allow me to record this video on week 1 chemistry topic for ss2 students. The topic is air and air pollution, and the subtopic is flames and types of flame. Okay, when we say air and air pollution, why flames? So air is a mixture, and in the mixture there is oxygen that supports burning or that support combustion. All right. If you look at the image below at the right hand side, you will observe that there is a candle light properly labeled. More of it is on the next page. Let's look at the definition of flame. A flame is a region where gases combine for the production of heat and light, and flames are produced when substances burn or when a combustion occur. All right, these are examples of flames. Look at this. This is an example of flame, and the necessary part of the flame are on the image. The outer, from the right hand side, we have the outer zone of complete combustion, which is always blue. The middle of the flame, we can call it the middle zone of partial combustion. The color is always yellow. And the innermost zone of the unburnt wax, that is always black. The left hand side, the hottest part, which is the outer part, and it is the blue. Then moderately hot part, that is the middle, or you call it the middle zone. The least hot, that is the place where the partial combustion occur, or where you have innermost zone, unburnt wax, and the last part of the flame, which is the flame stand or the wax candle. The same thing is here. When you check this image, the same thing. All right. Types of flame. A flame can be luminous or non-luminous. The luminosity of a flame is what we call the brightness of the flame, or the amount of visible light that the flame can produce. Does that mean that there are some flames that cannot produce light? Of course. Let's check what non-luminosity is next. But before then, a flame can be caused by the presence of solid. The luminosity of a flame can be caused by the presence of solid particles in the flame. Okay. A luminous flame is created when fuel is burned in a way that it is less efficient, resulting in light output. That is, the result of luminosity is always production of light, visibility. And luminosity occurs when there is not enough oxygen for complete combustion. Therefore, carbon particles, unborn carbons will show in such combustion. It may be in form of what is called soot, S-O-O-T, soot, or carbon black. All right. Properties of luminous flame. The properties of luminous flame are discussed under the following subtopic. We have The first heading: color, visibility, temperature, combustion, efficiency, oxygen supply, byproduct, and examples of luminous flames. Okay, when we say color, a luminous flame will give a bright yellow color. At times it may be orange, depending on the substance. Okay, luminous flame is always visible due to incomplete combustion. That yellow, we will always see it. So luminous flame have a very low temperature compared to non-luminous flame. So combustion is always incomplete. That is, burning is incomplete because there is limited supply of oxygen to the substance that is burning. Efficiency. Luminous flame is less efficient. That means it will not have more energy to carry out whatever reason why the combustion or the burning is happening. So unlimited supply of oxygen result in partial burning of fuels. In this case, a fuel can be anything. It can be charcoal, it can be wood, it can be petrol, it can be kerosene. So that will be discussed later. What are the byproducts of luminous flame? The byproduct of luminous flame are smoke, soot, or carbon deposits. What are examples of luminous flames? We have the candle flame, kerosene lamp, and wood fire, charcoal, and so on and so forth. All right. Non-luminous flame. When you look at the same subheading or the same heading for luminous flame as properties, we have the color. Color is the first one, like we discussed in the luminous flame. So for non-luminous flame, we consider the same set of parameters. So color is pale blue or light blue. At times it may be almost invisible. Okay, visibility, less visible. That is, at times you may not see non-luminous flame. You may not see it until when you are in it. The temperature of non-luminous flame is very, very high. Very, very high. And combustion is always complete. That is complete burning, because oxygen is always available. It is highly efficient as the fuel burns completely. Adequate supply of oxygen ensures full combustion. So number 7, for non-luminous flame, I don't think there is any byproduct. There is no byproduct, because what is supposed to be the byproduct might have got burnt in the process of combustion. Number 8, examples of non-luminous flame. We have the Bunsen flame or the Bunsen burner flame. We have hydrogen flame, and so on and so forth. So what I put into the discussion of properties of luminous and non-luminous flame is the same thing that is on this table as differences between the two of them. Candle flame. The candle flame burns with a luminous flame gas. There are 4 zones in candle flame, like we have seen in the examples. Okay, the unburnt zone, the outer zone, the bright yellow, the luminous zone on the outside, that is the one outside, the hottest part, and the blue zone at the base. like it is labeled here. All right. Hydrogen flame, which is an example of non-luminous flame. So hydrogen flames, all of them, they burn, or hydrogen burn with a pale blue non-luminous flame, and hydrogen fire have low radiant heat. So you can't sense the presence of a flame, I mean hydrogen flame, until you are very close to it, or even when you are in the fire. Hydrogen flame consists of two zones only: the zone of unburnt gas, and the second one, the zone of complete combustion. These are examples. On the right hand side, you observe that we have hydrogen flame and propane flame. The propane is burning yellow while the hydrogen flame is invisible. At the left hand side, the flame of hydrogen is put in a device for us to have it very visible, and you can see it is bluish in nature. Bunsen flame. This is a device, or Bunsen burner is a device with an air inlet at the base of the burner to ensure more complete combustion of the fuel gas. When the air inlet at the base of the burner is closed, you will observe a luminous flame which will be yellow. The Bunsen burner flame has 4 zones, just like the candle flame. Okay, look at this. So there is a link here. The link here, I will drop the link under this video. You can copy this link for some exercises. Copy and paste it on your browser, on your Google Chrome browser, or whatever browser you are using, Safari, whatever, and use it to learn. What are fuels? Fuels are chemical materials that store energy. The energy can be released through what is called combustion, or through what is called burning. So fuels, they are materials that store energy, that the energy can be released through burning or through combustion, and can also be released through chemical reaction or through nuclear reaction. So fuels can also be used to power engines, and can also be used to carry out industrial activities. Fuels can also be used to generate electricity. Fuels are essential for modern society. I don't think we can exist without fuels. For transportation, for all sorts of things. Okay, for cooking, for burning, for activating engines, and so on and so forth. So we need to understand the type of fuels, their characteristic, and the environmental impact as very, very important. Types of fuel. We have fossil fuel, biofuels, nuclear fuel, renewable fuels, and synthetic fuels. All of them are examples of fuels. So fossil fuels are from ancient plants and animals. Examples are coal, crude oil, and natural gases. Biofuels, they are made from organic materials, majorly crops and waste materials, organic, dead animals. Examples are ethanol, biodiesel, and biogas. Nuclear fuels, this is in terms of radioactivity, and we have uranium-235 and polonium 239. Renewable fuel from replenishable sources such as solar energy and so on and so forth. The hydrogen from the sun is also part of is an example. So renewable fuels, we have the hydrogen from the sun and solar energy. So then synthetic fuels, they are ones that we manufacture through chemical processes. Examples are uh, synthetic gases, you have diesel and so on and so forth. Okay, this is the classification. A fuel can be primary or secondary. If it is primary, it means it is natural. If it is secondary, it means it is derived or man-made. If it is primary, that means it is solid, liquid, or gas. So we have solid fuels, we have liquid fuels, and we have gaseous fuels. Examples of solid fuels. Examples of solid fuels are wood, peat, lignite, and coal. Examples of liquid fuels, we have petrol, kerosene, and all of them, they are from crude oil. Gases, we have natural gases such as methane, ethane, propane, and the like. So when we say secondary or derived fuels, we also mean some uh, other examples that can fall into maybe the way we use them. You understand? So, and we have other examples like coke, charcoal, petroleum. That those all of them, they are solid. Then tar, kerosene, that is liquid now under secondary. Then diesel, and we have gases. We have coal gas, we have oil gases, and we have biogas. Let's see other classification. In this place, we have primary like solid, liquid, and gas, and those are the examples. Let's check the secondary or artificial, which is the same thing as man-made. Let's check those ones. We still have solid, liquid, and gases, and the classification is very similar. All right. Chemical fuels can be classified based on their occurrence as primary. So occurrence as primary means they are natural. Okay, primary fuels or secondary fuels. Let's take the primary fuels now. These fuels occur in nature and they are used as they are as in they are used as they are. Examples are wood, natural gas, and petroleum. Secondary or artificial, they are fuels that are derived from primary fuels, and examples are charcoal from wood, coke from petroleum, kerosene from petroleum, diesel from petroleum, and petrol also. All right. Characteristics of fuels. So fuels need to be energy density, that is energy stored per unit mass over volume. So that is one characteristic. That is, for a substance to be called a fuel, it should be able to contain the enough energy that is stored inside. Then combustibility. So it is not all substances that can burn in air. For example, ceramics, clay, although they will become very hot, but for them to change state, it will take time. So environmental impact, bioproducts, that is greenhouse, diesel, or whatever effect, we have to be very careful the way we use our fuels. So uses of fuel for transportation, for generating electricity, for heating, for industrial processes. Then these are references. Let's go to questions. What is a fuel? From this place, the best option is B. Fuel is a region where gases combine chemically to produce heat and light. The next question. What causes the luminosity of a flame? A. High oxygen supply, solid particles in the flame, presence of water vapor, low fuel efficiency. What's the answer? Option B, that is presence of solid particles in the flame. The next question. Which of these is a property of a luminous flame? Pale blue color, high temperature, incomplete combustion, and produces no soot. Let's see the answer. Option C, incomplete combustion is the property of luminous flame. Number 4, what is an example of a non-luminous flame? Example of non-luminous flame. Let's see the correct answer. B, gas stove flame with air hole open. That is the best example of non-luminous flame, which is the Bunsen flame. Okay. The last question. Why does a luminous flame appear yellow? Oxygen availability, complete combustion, presence of unburned carbon particle, or high temperature. Presence of unburned carbon particle. Thank you and God bless you.